Hey guys, this is Mrs. Harbin, and I'm here with Algebra 1, Section 1.5. Our biblical reminder for today is that God is truly an awesome God, and His plans are far-reaching, even down to a system of numbers. If He can create detailed and intricate plans, including all these numbers and patterns that we have, then He can definitely create everything else. And if we are following His system of numbers, it would be wise to follow the other plans that He has in place as well. Our objective for today is this. You, the student, will multiply signed integers and rational numbers and identify and apply the properties of multiplication. Don't forget, an integer is all of our natural numbers or counting numbers, 1, 2, 3, 4, 5, plus 0, and then their opposites, negative 1, negative 2, negative 3, negative 4, negative 5. Rational numbers are any numbers that can be written with a denominator and a numerator. So we have our fractions like 3/4, but then we also have our integers like 5 that can be written as rational numbers if they're written as 5/1. So we'll look at how to multiply these and the properties of multiplication. When we speak of multiplication, we know that multiplication is just repeated addition. 3 times 5, or as I like to say, 3 groups of 5. Here's one group, here's one group, here's one group. We are combining equal groups, 3 equal groups of 5. 3x in algebra. When we see a number and a letter next to each other, the implied operation is multiplication. So 3x means 3 times x, or 3 groups of x. So one group of x and one group of x, and those are supposed to be plus signs, one group of x. 3 parentheses, or 3 times 2 plus 5, literally means 3 times 2 plus 5. When we have a number and then a grouping symbol and then some more numbers, that implied operation again is multiplication. Looking at our properties of multiplication, the first property we need to talk about is the commutative property. If you multiply two numbers together in a different order, the product is still the same. So A times B is the same as B times A. If we put this with numbers, our factors 3 times 5 is the same as the factors 5 times 3. These numbers that we multiply together, these are called factors. And the total amount that we get when we multiply these factors together is called the product. So 5 times 3, factors 5 and 3 make the product 15. The second property of multiplication is the associative property. If you group numbers differently when multiplying, the product is still the same. So let's say we have more than two numbers that we're multiplying together, like A, B, and C. We can put parentheses around the B and C, or put parentheses around the A and B, and it's still the same. Let's put some numbers to this. So 7 times 2 times 3. We could put the parentheses here, or we could put 7 times 2 in parentheses times 3. And our product is still the same because our factors have not changed. We still have the factors 7, 2, and 3. The third property of multiplication is the multiplicative identity property. This property just states that the product of any number and 1 is that number. So 5 groups of 1, if I have 5 groups of 1, I have a total of 5. Or if I have one group of 3, I have a total of 3. So the product of any number, here's a number, and 1 is just that original number, that original factor. Without numbers in place here, using just our letters that we've got there, we've got A times 1 equals 1, or 1 times A equals A. A times 1 equals 1 times A equals A. There we go, I said it right that time. Another property of multiplication is the distributive property. The distributive property states that the product of a number and a sum is equal to the sum of the products of the number and each added. That can be kind of confusing, so let's break this down. Product is just our final answer. So the product of a number, we know what a number is, and a sum. So let's say the product of 2 and the sum of 2 plus 3. Remember, sum is just an addition sentence. Sum is what we get when we add two numbers together. So the product of a number and a sum is equal to, we know what that means, 2 the sum of the products of the original number and each addend. So I can take that original number and multiply it by each addend. So my original number was 2, and I could multiply it by the 2 that was inside the parentheses and the 3 that was inside the parentheses. And my two products will be the same. If you don't believe me, let's go ahead and solve these. 2 times 5 is 10. And over here, 2 times 2 is 4. And 2 times 3 is 6. And when I add those together, I get 10. This helps us when we want to break down larger numbers or maybe combine smaller numbers. The distributive property will help us out when we're multiplying partial sums and other things in the future. We also have the zero property of multiplication, which states that the product of any number and 0 is 0. And that makes sense. If you have 0 groups of 6, how much do you have? 0. Or if you have 5 groups of 0, 5 groups of nothing is still nothing. Pretty straightforward there. A product is the answer to a multiplication problem, while a factor is any number that is being multiplied in the problem. And I stated that earlier, but if we're doing some numbers here, you know that 3 and 6 are factors of the product 18. You should be able to not only come up with a product from given factors, like we just did, but you should be able to work in reverse. For example, if I give you a product of 18, what factors do you know? See if you can list them. Factors of 18 are 1 and 18, 2 and 9, and 3 and 6. Each of those numbers, when multiplied, will get us to a product of 18. So you should be able to work both ways, come up with a product and come up with the factors. If the factors are both positive or both negative, basically if the factors have the same signs, then the product will be positive. So two positive numbers multiplied, 7 times 4, both positive, we will get a positive product. If I take two negative numbers, negative 7 times negative 4, they have the same sign, so I get a positive product. If you'd like more information on how that works in the real world, see me. I've got a great video for that. But if one factor is positive and the other is negative, so if the signs are different, then the product is going to remain negative. So positive 7 times negative 4, we've got two different signs here. So our answer is a negative 28. Let me make that clearer. Let's take a look at an example. Negative 2 times 9. Try that on your own. That should be a negative 18 because we have two different signs, a negative and a positive. What about this one? Negative 4 times negative 6. The signs are the same, so the product is positive 24. If there is an even number of negative factors, the product is positive. So an even number, that's 2, 4, 6, 8. So let's say I have 4 negative factors. 1 times 1 times 1 times 1. I have an even number of negative factors. My product will be positive. But if there's an odd number of negative factors, the product is negative. So odd numbers are 1, 3, and 5. Let's say 3 factors. Negative 1 times 1 times 1. Negative 1. I don't know what's happening with my mouse here. My product will be negative. Take a look at this example. We've got 3 negative factors, so our answer will be negative. And 2 times 3 times 5 is 30. Negative 30 because of the 3 negative factors. 4 times negative 3 times negative 1, that's an even number of negative factors, so our answer will be positive. When we multiply that out, number 12, positive 12. You should be trying these on your own, pausing and working these out to see if you can get them before I move on. Let's try some multiplication with fractions. Now, when multiplying fractions, it's not necessary to have a common denominator. Multiplying fractions for most students is actually easier than adding, because you just multiply across the top and multiply across the bottom. If you can, simplify or cancel first. It's usually easier. When multiplying with fractions, mixed numbers must be converted to improper fractions before multiplying. Let's come back here and take a look really quickly at some examples. So let's try 1/2 times 3/4. We don't have to have a common denominator. We just multiply across the top. 1 times 3. And then we multiply across the bottom. 2 times 4. And there's our answer. If we can cancel, let's try to cancel. So 1/2 times 4/9. When we look at canceling, we're looking at cross factors. So we're going to look at this 2 and 4. And 2 and 4 have a common factor of 2. So I can divide both of these by 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. Then I can multiply across like normal. 1 times 2 is 2. And 1 times 9 is 9. I could have multiplied first. If I had done that, I would have gotten 4/18 and then reduced. But with larger fractions, it's easier to cancel first. Mixed numbers have to be converted to improper fractions. So a mixed number is a whole number plus a fraction. To convert that to an improper fraction, the quick and easy way is multiply the denominator times the whole number and add the numerator. 2 times 2 is 4, and 4 plus 1 is 5. And then our denominator stays the same, 5/2. If you're not sure why that is, let's take a look at maybe 3 cookies that have been divided in half. And if you ate this half, and this half, and this half, and this half, and this half, how many halves did you eat? You ate 1, 2, 3, 4, 5 halves. That's where that 5 halves comes from. We do need to convert these to fractions before we multiply. A unit multiplier is a fraction with 2 different expressions, so like feet to inches, or cups to quarts, or miles to hour. 2 different expressions for the same quantity in the numerator and the denominator. It's used to convert or to change units of a number. So if we're wanting to convert inches to feet, we have to write our conversion multiplier or our unit multiplier. We're converting to feet, so that goes on the top. And then we're starting from inches, so that goes on the bottom. And we have to think about what our unit rate is. Well, we know that 1 foot, 1 unit, 1 foot is equal to 12 inches. Once we have our unit multiplier in there, like so, we can go ahead and multiply just like we would with any other rational number or fractions. Reduce if you can, and then multiply. Our inches will cancel. That leaves us with 60 over 12, 60 feet over 12 divided by 12. 60 divided by 12 is 5 feet. Convert that to inches. So our unit multiplier, since we're starting with feet and going to inches, our inches is on the top here. And 12 inches equal 1 foot. Cancel our feet and multiply. 5 feet is 60 inches. Try these on your own. Convert from inches to centimeters. Our unit multiplier there is 2.54 centimeters per 1 inch. And when you multiply that, you get that number, 135.255. Convert that to feet. Using 1 foot equals 12 inches, we find out that 51 inches is equal to 17 over 4 feet, which is 4 1/4 foot. Okay, let's try this one on your own. For this one, we've got to convert miles to feet first. And then once we've converted miles to feet, we can convert feet to inches. That should be your total answer. Today, you multiplied signed integers, you multiplied rational numbers, and you identified and applied the properties of multiplication. If you have any questions, be sure to ask me next class.